This video is a quick overview of SDM, a tool to help you manage Raspberry Pi OS images. I've edited some of the videos to remove long wait times, but other than that, the videos are unedited. Hopefully I made them short enough to keep your interest. SDM helps you create customized RasPi OS images that you then burn onto ready-to-use SSDs or SD cards. By ready-to-use, I mean configured such that you can boot it up and be productive with no fussing with any configuration settings. You know what I mean by that. SDM helps you configure wireless, SSH, localization settings, passwords, install any apps you want, and so on. In other words, ready to use. Fundamentally, SDM enables you to update an official RasPi OS image to create your own custom image. You can then burn your customized image to as many SD cards as you want. All customizations that are common to all of your systems are made in the image. Settings unique to a specific Pi are done when you burn the SD card. For instance, the host name isn't written to the image. The host name is written to the SD card by SDM when you burn it, giving it its identity. RasPi OS is based on Debian, and SDM runs on RasPi OS, Debian, Ubuntu, and other distros derived from Debian. SDM uses the tool systemd nspawn to, quote, go inside the image file, and systemd nspawn imposes a couple of constraints. Specifically, SDM running on an older version cannot customize a newer OS in an image. For instance, Buster cannot customize Bullseye. In addition, SDM running on a 32-bit system cannot customize a 64-bit system. If you only care about customizing 32-bit images, the best system to run SDM on would be the 32-bit RasPi OS Bullseye. If you want to customize 64-bit images in addition to 32-bit images, the best system to run SDM on would be 64-bit RasPi OS Bullseye. Yes, that release is still in beta, at least as of November 2021, but it's still quite stable and usable. You'll also need enough storage to hold all the RasPi OS images you want to work with. When you're ready to burn an SD card, you'll need a USB SD card reader. If you want to burn SSDs, you'll need a compatible USB to SATA adapter. Lastly, if you install the totally optional APT Cacher NG, which I'll talk about later in this video, you'll need enough additional storage for its cache. You can make SDM easy to use by adding an alias to your .bashrc. SDM has three primary commands: customize, explore, and burn. The customize command updates the official RasPi OS image with your desired customizations. The explore command lets you go inside the image to look around and make any desired manual customizations. You'll be in a bash shell as root inside the image with this command. Xterm and some other terminal emulators are capable of processing VT100 escape sequences, and SDM will change the terminal color so you know you're in a different mode with these emulators. You can also use the explore command on SSDs and SD cards. This is handy, for instance, to reset a forgotten password. The burn command burns your customized image to an SSD or SD card. You can make modifications as part of the burn process, such as setting the host name and several other settings as well. The extend and mount commands are typically used infrequently, but I'm mentioning them here for completeness. Does this sound like you? You have a set of steps to do every time you boot up a new SD card burned from a RasPi OS image. You've gone through them many times. Sometimes you forget a step and then you have to go figure out what you missed. SDM enables you to turn that whole list into a set of scripted changes to the image. You can do a tremendous amount of configuration without writing any code other than the SDM command line. If you are able to do basic bash programming, you can do, well, pretty much anything you want. Because you can burn SD cards for multiple Pis from a single image, you can also reduce your bandwidth consumption. And more importantly, at least from my perspective, reduce your wait time. SDM makes you more productive because you spend less time doing configuration and more time doing the things you want to do. Finally, as you'll see in the video segments, SDM logs everything it does, which is far better than a list of steps to manually apply to new systems. In addition to customizing an image, SDM can resize it for you. In the next demo segment, you'll see how to extend the image and then do a basic customization. You'll see the console output generated from both the resize and the customization, and then we'll look at the log that SDM creates inside the image. Now you'll see what happens if the image isn't big enough to accommodate all the updates and apps you want to install. SDM noticed that the disk was full and flagged it on the console and in the log. Extending the image to the amount needed will fix this. You just saw how to extend an image in the previous video segment. If you're not sure how much to extend it, make it a good amount larger and do your customization. You can then figure out how much you're actually using and adjust the extend size. You can set the host name for a system when you burn the SD card. There are many other settings that you can change as well, and SDM can also run scripts you provide after the SD card has been burned to do further system-specific customization, such as installing apps you only want to use on a specific Pi. Now we're going to boot the SD card we just made. It was built from a bullseye desktop image, so there isn't a lot to see when it's booting, especially since I've edited out most of the screen flashing and wait time. I apologize in advance for the less than stellar quality of this video segment. The three messages that you'll see on the screen before it reboots at the end of the first boot are status updates from the SDM First Boot service. When the system comes back up after the automatic restart, I'm automatically logged in as you'd expect, and we'll see that my locale and WPA supplicant were set as I configured them, as were all the other settings we configured. If you rebuild SD cards frequently enough, you may want to have your customized image with all the latest APT updates installed. You can do this in batch mode or interactively, or you can simply rebuild the image whenever you want. It's especially painless and quick if you use APT Cacher NG, which you'll learn about in just a minute. APT Cacher NG comes with Debian, RasPiOS, and other Debian-based distros. There's nothing in it that is RasPiOS or SDM specific. I only mention it here because it has saved me so much time waiting for packages to download. As you can see from the data, using an APT caching server reduces an APT update from 40 seconds over the internet to 5 seconds when using APT Cacher NG. It's a huge win, and the win gets larger as more packages are updated for a release. And if you configure your existing APT-based systems to use the caching server, they'll also install updates much more quickly. Well, after the first system primes the cache. The first demo you'll see is when using APT Cacher NG. This video is not edited at all. The second demo is with the Pi not using a local caching server. Again, the video is not edited, so you can see all of the packages being downloaded. That's it for this video. I hope you found it useful. Check out the complete documentation for SDM on GitHub.